In the past 15 lessons, you have been following step-by-step instructions to build and program different kinds of robots. In this lesson, you are going to design your own robot. Are you ready for the challenge? Before you start building, we would like to introduce you to the engineering design process. It would help you to think like an engineer, and ensure that you stay on the right course as you design and build your robot. Essentially, the engineering design process comprises the following steps: define, explore and plan, create, and improve. There is no single universally accepted design process. This is just an example to help you get started. Do you know that an engineer is basically a problem solver? An engineer uses available resources and experience to find creative solutions to complex problems. The engineering design process helps engineers to methodically analyze and solve a problem, and then further improve on their solutions. In our case, applying the engineering design process will help us to come up with creative robot designs to accomplish the given task. The first step in any engineering endeavor is to identify and define the problem. We start by asking, what's the problem or challenge? What do I want to achieve? And also, what are my constraints? If you are participating in a robot competition, you have to first read through the game rules thoroughly, and understand the requirements and restrictions of the challenge. After that, make a list of objectives, or design specifications, and sort them in order of importance. As a rule of thumb, tasks that earn higher points are more difficult to accomplish. Bear in mind also that a robot design may not be able to achieve all of the objectives. Thus, it is important to prioritize and work out a feasible design that can fulfill all required tasks, and optimally is able to excel in some bonus tasks too. Besides, you must remember to take your limitations into consideration. These limitations could be the time available until project or competition deadline, budget, material, or part resources, and the skills level to turn a robot design into reality. By setting a boundary on what can and cannot be done, you will have a clearer roadmap for the project. Otherwise, you may waste a lot of time and resources solving matters that are too difficult or simply beyond your capacity. The next step is to explore and plan. The most common approach is to do research and have brainstorming sessions. Research can be carried out independently or collaboratively. The scope of the research should include, but not limited to, locomotion and drive system, manipulator, such as gripper or lifter's design, sensing capability, and stability. Look around you for inspirations. You can always take an old idea and innovate upon it. Having the best robot is not a guarantee of victory in a robot competition. You need to draw up a set of winning strategies before you even enter the game field. Generally, a good strategy should help your team to accomplish all compulsory tasks in the game and score the highest points. Game strategy will also steer the direction of your robot design, so it is vitally important to decide the core strategies first before voting for robot design. During the discussion on robot design or game strategy, do not settle for mediocre or simple ideas that come easily. If you can come up with the idea without much effort, everyone else can too. Keep an open mind and allow crazy ideas to develop. Do not forget to think outside the box to come up with novel ideas. In a brainstorming session, be careful not to get too emotionally attached to a single idea, especially one that you propose, and become defensive against better ideas from someone else. Combining two ideas, or compromising between two different suggestions may sometimes yield a better solution. Think rationally, and always go for the best idea to achieve the ultimate goal. Be like an engineer, and systematically note down your research findings, and design ideas in a logbook. Alternatively, you can keep the record on your smartphone, tablet, or PC. Make sure that it is stored safely and organized neatly for future reference. This record is called an engineering notebook. After you have come up with a plan, it is time to move on to the next step, which is to create, or in our case to build a robot. The standard engineering practice is to build a prototype first. A prototype is basically an early sample, or model of a product built to test a concept or idea. Aside from building the robot hardware, you need to consider its software, that is the programming too. Basically how well you do the programming translates to how intelligent your robot will be. Sometimes we can solve a hardware design issue through a software approach. In other words, a better programming can make up for a design flaw. So do not only focus on refining the hardware alone, and neglect a powerful tool in your hand, which is the programming. If the deadline is approaching, opt for either hardware or software approach that will solve the problem effectively in the shortest time possible using the least resources. Once you have built and programmed your robot, it is time to test and see if it truly does what you want it to do. The best way to do this is to try it out in the real situation or game field. Observe what works and what does not. If it is not performing the desired outcome, you will have to determine the problem and try to rectify it. And even if the prototype seems to work fine, you should not stop there. An engineer will think of ways to make it work better. The idea is to keep modifying your design until you are fully satisfied with the performance. Engineering design is an iterative process. Why is it so? After a design is implemented, the testing and evaluation will most probably generate additional ideas to improve the current design, so the designer will go back to the initial stage of the process to define the new problem or specification. Research and brainstorm for solution. Implement new design. And then evaluate and improve on it. This engineering design process could repeat forever,